Now, in our last episode, I think we went through the contents of the syllabus, and I briefly explained how it can be. I expounded it so that it can give you a reference to look for additional books or material that you might be needing. Now, today, I want us to have a look at the various words in our heading. We have got engineering, drawing, and design. And then, we said engineering, drawing, and design, we use them to manufacturing and communicating. So we need to have standards so that whatever we do can be understood by anybody else. And today, the world being a village, anybody throughout the world. So I'll briefly also mention about standards. And then in the standards, we need to have some symbols that we use in our drawing. So I'm going to start off with, in our topic, we've got engineering, drawing, and engineering design. So I'm going to start off with engineering drawing. So the question we might ask ourselves is why study engineering drawing? I think in your first year, you underwent some part of it, the engineering drawing. So let's look briefly at why you need to study engineering drawing. Now, in our design, engineering designers use engineering drawings as the way to communicate and document ideas. Designers think about the way that a mechanism or product works and how it can be manufactured or built. He must have skills in 3 areas of communications. Now, one of them is English, both written and oral. Of course, here I'm stressing English because in Kenya, most of East African countries, we normally use English. So if you are from, let's say, China or some of those Spanish-speaking countries, that language will be slightly different. But the written, you must be skilled in both the written and the oral. You have to express yourself. Remember, what you are making or the service you are rendering, you have to be able to convince somebody to purchase them from you. Then, in order to communicate, we need to have symbols as you need to have to master the symbols as used in science and mathematics. Now, this is where the standards comes in. We need to use the symbols that are understood more or less worldwide. And then you need to master the bit of engineering drawing, both sketching and design. Now, in much of the lessons I'll be conducting with you, most of my drawings will be sketching. I'll try to interpret them. But in your case, in your final drawings, you have to use the drawing instruments. In Module 2, we expect you to use the AutoCAD, the computer. But all your drawings must be, for the straight edges, use straight rulers. For the circles and arcs, use your compasses or those other curves which are available in the market. Now, when you are learning in the engineering drawing, you find that a designer must be able to assemble the written, numeric, and drawing information and make the final working drawing. Now, when you are doing your design, you will have some symbols, or somebody can give you that information in form of a writing, or it can be numeric, and then from that one, you have to produce the working drawing. Now, the working drawing is the one from which the product is made. Now, engineering technicians assigned to aid the engineer or to work in production must have considerable knowledge in preparing engineering drawings, Now, this is where I think most of us follow in. We are trained to be engineering technicians to be able to aid the engineer in doing his work. Now, when we study engineering drawings, there are some 3 things that we'll master. The first one, the learner, the student, the one doing the studying, becomes aware of how industry communicates technical information. The drawings you draw, be coming from the design office to the shop floor, so learn how we communicate from one place to the other. Secondly, the engineering drawing teaches the principles of accuracy, clarity in presenting the information necessary to produce the products. Earlier on, we said there should not be ambiguity in the information you are conveying in your drawing. So engineering drawing will teach you that one. And then the best bit of it, the one which you need to master, is it develops the engineering imagination that is essential to a successful design. Now, in design work, the limit is your own limit. And part of the drawings as you draw them will show you the way they can be drawn, but then you can also develop your own way of doing things. So it is essential you have that engineering imagination that is essential to access successful design. If you lack imagination, I think you can have some problems in the engineering field. Now, the best way, it is ideal to master the fundamentals of engineering drawing and to later use the fundamentals for a particular application such as CAD, which is what we are expected to do. The deeper your understanding of the fundamentals, the more command you'll have of whatever tools you have. Now, a good example of this one is when it comes to the jua kali sector. You find the fellows who did engineering, they went to the jua kali sector, they're able to use their imagination and come up with products compared to those other fellows who have got workshops, but they are unable to do the same. And I can say that in Kenya now, our jua kali sector is producing much, much more than what we have in those guys who are working in the formal sector. And I think it's an area we want to maybe explore much further. And what I can say the problem is that imagination is not there in the fellows who are involved in the formal sector. So it's up to you now, as we go through this ones here, to try and develop that imagination. And as I just said earlier, what we are doing here is not enough. In fact, what we do here is about 10%. The other 90% is for you to read, and when you go for attachment, you learn much, much more, and then you can raise questions, and we can discuss them. Now, the next word in our title is design. So briefly, let's have a rough idea of what engineering design entails. Now, one of the key things you know about engineering design is that engineering design is a decision-making process used for the development of a product or an engineering system for which there is a human need. In other words, whatever it is that you want to design, you must have in mind what it is going to satisfy. In other words, we don't do design and then pack them in our shelves for them to gather dust. Now, to design is to conceive, to innovate, to create, or any other word you can think of. So there are many variations in which you can talk about the design. One may design an entirely new product or system, or modify or rearrange existing things in a new way for improved usefulness or performance. Now, engineering design begins with the recognition of a social or economic need. Now, one of the things I know is that next year, in your third year, you'll be doing a project. Now, a majority of those projects are simply made for us to test whether you have understood what you have learned in your 3 years at a technical institution. But what I would urge you now to do is that when you are picking on a project to do, pick on a project which is going to fill a human need, such that once you finish your project in the institute, you can go outside rather than wait for employment. You continue working on that project and start making money out of it. Now, a few students have followed that idea, and most of them, all they did in college, technical institution, they went forward and continued with that project, and now they're adding money out of it. Now, engineering design is with the recognition of a social or economic need. The need must first be translated into an acceptable idea by conceptualization and decision making. Now, you might come up with a design, but then you might find that it's not workable. Maybe you want to transport somebody from Nairobi to New York, the shortest time. The jumbo jet is taking a lot of time, but now that one is something for the future. You have not yet come into that stage. So whatever it is that you want to design, it must be achievable in the present time. Then the idea must be tested against the physical laws of nature before one can be certain that it is workable. Now to do that one, this one you establish that one by reading. And nowadays we have got software programs where the ideas you have, you can test them, and then you can know whether they are workable. But one of the things you know is that you need to understand the physical laws of nature before you can be sure that it can work. This requires that the designer must have a full knowledge of the fundamentals of physical laws, of the basic sciences, and it also needs to have the ability to communicate ideas both graphically and verbally. Now, some of those designs you come up with, you may not be able to visualize them, to actualize them yourself alone. So you need to convince others about your design idea. And that's where the ability to communicate both graphically and verbally can help you get the team on board. Now, proficiency in designing can only be attained through practice. Since it's only through practice that the designer acquires the art of continuously providing new and novel ideas. In other words, once you think of an idea, you get it done. Of course, what you can do is maybe you can go and rearrange it so that it can be a better product, or you need other ideas. So that one, continuously practicing on the design, will help you to be able to come up with new and novel ideas. Then you need to apply the knowledge of engineering and materials science, which you have been doing in other subjects, while taking into account human factors. What you are going to make is going to be used by humans. Well, in some cases, it may be part of a machinery system. And then there is a question of reliability. How reliable is it going to be? Then the visual appearance. Most people, they look at appearances. Well, a good example is the vehicles. Now you have the same Toyota, but there are different versions of it, dictated by what the market wants, visual appearance. Then the manufacturing methods available. Sometimes you can have a design idea, very good, but then it cannot be actualized locally. Now the beauty of it is that those ideas, once you have them, you can register them as intellectual property, and then you can sell them to those others who are able to actualize them. Reliability, visuals, methods, manufacturing methods which are available, and then the sale price. You might come up with a design, but then nobody can buy it. So you need to take the sale price into account. Now, one of the words I've omitted is one of durability. Now, durability, whatever you design, should be durable. Now, you can design something which can go on for 20 to 30 years. And a good example is those guys, the Ignis company, which were making fridges. Now, their fridges were reliable and both durable. But what happened eventually? Everybody bought a fridge. It was not breaking down, so there was no need to go for another one. So eventually, the company had to kind of wind up or come up with other ideas. But of course, the question of durability, don't make it such that after using the component 1 week, you've got to go back to the market to get another one. I think some various countries are known for that one. Whatever you buy from them, you know, you give it a lifespan of maybe 6 months, and you know you are going to get another one. Now, the ability to design is both an art and a science. Now, whatever you are making, art, the way it appears, will create the market for you, and also its functioning, which is whereby the science comes in. And then you should know that a creative person will almost never follow a set pattern of action in developing an idea. There are those other people who have done some things before us. When you read about them, if you are really creative, that will only be a guideline, but you not follow the same way, especially if you want a new and a novel something to come up. Now, the design process calls for unrestrained. That means your imagination, which you talked about earlier on, must be there, unrestrained, and it must be creative, and then with some ingenuity. And then one of the things you find out that is that in the design process, it's a continually decision-making process by a freewheeling mind. You come up with a design, you find it cannot be made here locally. You go back again to the drawing board. You look at the companies that can manufacture it in Kenya, and then you redo it again. So you find it's a continuous process until you arrive at the final product. Now, how can one teach about design? Now, the design, as I said, is only through practice that you can acquire that knowledge. And to know that you are good at designing, I normally give a small example to you guys, which is which I got sometimes when I'm perusing my internet about the 9 dots, which are in kind of a square formation, like that. There are 9 of them. Now, the idea is that you should join the 9 dots using only 4 straight lines. Of course, that looks easy when you look at it, but the catch here is that once you put your pen down, you should not lift it out of the drawing your lines until you finish all the 4 straight lines. That is good. Before you can try to get a solution to any human need or problem, you understand what the problem is. In this case, you have got the 9 dots. They should be connected with 4 straight lines. And once you put your pen down, you should not lift it up until you have finished all the 4 straight lines. Now, I'm sure there are a lot of lines, patterns you're drawing in your mind, how to connect those 9 dots. Now, that process which is going into your mind is what I was calling about the continually making decisions. You draw one, it can't work. Then you go back again, you try another one. Go back again, try another one. Now, that process, I think teaching it would be kind of a problem unless you try it. This is something, design, you are being taught how to do it. And the only way you can learn it is by doing it yourself. So try that one and see how you can come up with it. Remember, it's 4 straight lines, and the straight line should be more or less kind of continuous. And once you put your pen down, don't lift it up until you have finished all the 4 straight lines. And that will briefly give you a kind of idea of what a design process is all about. Now, we have talked about the engineering drawing, about the engineering design, and then we have found that we have to draw drawings graphically, and we use them for communicating. Now, to be able to communicate, we need some standards, and standards which are known kind of worldwide. Well, in Kenya, as I said earlier, we have got our KEBS. That means in Kenya, it is expected we are all familiar with KEBS. And then we have got the BS from the British Standard Institution. Again, these were used, they were available in the former, well, still the Commonwealth countries, the former British colonies, of which we were part of. That means they have got a wider area where the symbols are being used. And nowadays we have got the ISO. Now ISO is more or less kind of the standard for the world, which has become a global market. So briefly, I'm going to discuss about ISO. I think with the CABs, you dealt it in your first year engineering drawing or some other lesson, you came across it. BSI, I think most of the symbols we have in our books, they conform to BSI. The ISO, I think we adopted recently in Kenya, but now they are becoming the in thing. Every institution, like where we are here, we're supposed to be ISO compliant. Most TVET institutions, they're also trying to be ISO compliant. What you need to know is the standard which is applicable to you, go through it, and try to do what it says, and then you'll be satisfied. So let's start off by talking about ISO systems. Now, ISO is an international agency that produces standards and of course the standards are meant to be international. I think most countries in the world, they are part of the ISO, they have adopted the ISO standards, and the idea of this ISO is to foster increased trade across countries. Now, if you have got ISO and you want to buy something maybe from Brazil, you know that if it conforms to an ISO standard which you are familiar with, you can simply buy it from there and you import it. Likewise, any other country, whatever you're making here, if it comes to a kind of an ISO system, they can simply buy it. Everybody's aware of the system, of the standard system, and then he knows whatever he gets will be complying to that one. If he doesn't, you can sue and get your worth back. Whereas, if you're making something of Kenya Bureau of Standards, and then you send it to maybe Spain, the fellows might have no clue of what we have here, and you'll be kind of reluctant to buy the goods from here if they are made out of the BS. You go to China, you talk of the BS, then they will not be very much keen on it since they are not much aware of what the BS is all about. But with the ISO, all the countries that are involved, there is that kind of uniformity. Now, the last time I read about the system is that I found that it consists of over the membership 160 countries across the 5 continents. I think you have got 5 continents across the 5 continents. It consists of 160 countries, and others are still joining it. And the membership into ISO is through the country's standards body. For example, in Kenya, Kenya is a member through CABS. So CABS is the one which is registered by the ISO. And similarly, CABS, so Kenya is a member now in countries whereby there are more than one standards body, then the registered body will be the one which is the most representative of standards in the country. Well, the only fortunate thing is that in Kenya, you have got only one standards body. Now you find in bigger countries, like in the US, there are various states. Each state has got its own standards body, but then they have got a national one. Now that national one is the one which will be registered in ISO. So the standard body with the most representatives is the one that will be organized by, which will be recognized by ISO. And it's only one such body per country. Only one such body per country. Now, if I may quote, for example, the case of our teachers here. With the teachers, we have got so many unions. We have got, for example, NAT. We have got CUPET. We have got Now, the students can help me to fill up those others. Now, what you find that if this one so to be registered into maybe to ISO as an example, then the one with the most members is the one that will be recognized. The others, whatever grievances they have, then they have to forward it through the one with the most representatives. Well, I know in Kenya, the NAT used to have most teachers, but now the situation is kind of fluid. We don't know which is which. So similarly, with the standards, that's kind of is kind of an example that can apply to a country whereby there's more than one standards body. The body with the larger number of standards is the one that will be recognized by ISO. Now, the classes of membership are divided into groups. We have got three kind of groups. One is the full member, known as a member body. Then we have correspondent, body member, and we have subscriber. Now, depending on the level of your standards is how you can join into any of these three categories. Now, if you have a look at the member bodies, once you're a member body, this body will be the country's in the case of Kenya, this will be KEBS. And while they are at the meeting, they are entitled to carry out to participate and exercise full voting rights on any issue in policy and other matters. Once you have joined it in the status of a member body. Now we have got the other class, which is correspondent. correspondent member. Now, this one is usually an organization in a country which does not yet have a full-fledged standards body. Now, in Kenya, before the KEBS came in, we used to have the Kenya Association of Manufacturers. It was the body that was known. So in that case, that level before the KEBS came in, the KEAM would apply for membership at ISO, and then the membership they would have gotten would be the correspondent membership. Now, these ones, they do not participate in any policy or other matters, but these ones do not participate or vote in policy matters, but are informed about what is happening in ISO. And then the last membership, correspondent. Now this one has been established. This one has been established for countries with very little economic activities. Now, the latest country in the country is the Southern Sudan, but of course we cannot say that it has got little economic activity. There is very much which is going there. I'm sure they are yet to establish the standards body for it to be registered under ISO. But we know Southern Sudan, there is a lot of economic activities which is going on, so their case may be kind of fast-tracked. Now that briefly describes the membership. So let's look at the origin of ISO. Now ISO was formed by the merger of two organizations. One is known as ISA, and this one is a body was a body in the US known as the International Federation of International Standardizing Association, which is ISA, and this one had been established in New York in 1926. More or less, the federal states of the US, each was having its own, so they decided to come together and have an international body to cater for all those states. And the other organization, and the other one is UNSCC, which is the United Nations Standards Coordinating Committee. This one was established in 1944. Well, we know the United Nations was formed towards the end of the Second World War, 1939 to 45, 1944. The big leaders in the world, they found the need for standards. Remember, in the war, there were several countries in one group, another several in one group. What they found out was that during the war, the equipment that was being manufactured, when it was sent to the site, it could not more or less coordinate. So those, the big five, they kind of came together, the Allied forces, under the UN, the United Nations. So this is one set of the United Nations Standards Coordinating Committee to more or less coordinate manufacturing across the world. So this one had been established in 1944, and these ones, they merged in 1946. It was formed by the merger of two organizations, that one and this one's here, and they merged in 1946. That means the two, they met, I think it was somewhere in Europe, and they came up with ISO. Now, so the two merged and formed ISO. Which began operations around 1947. Now, its full name is, most people, they read it as National Standards Organization, but its full name is International Organization for Standardization that is the full name. And of course, ISO was an abbreviation from a Greek word known as isos, which means equal. But as you know, in most of these international organizations, there's nothing very much equal. The bigger boys dictate terms for the other fellows. Now, that ISO, since its inception, so between inception and the present day, ISO has produced more than 17,500 standards. Now, this cover such things as agriculture, medicine, ICT developments. I think ICT is the newest kid in the block. In other words, the ISO covers nearly all the sectors of the economy. Now, before we proceed, let's look at how it works. In other words, how does it produce standards? How ISO works. Now, the standards are prepared by a standards technical committee of ISO. Now, this committee is formed by the ISO, the mother body, in case there is something they want to discuss. And once the committee is formed, any member, of course, when you talk about members, we are talking about the full member, any member who is interested in what is being discussed can participate in the discussions. Of course, we say they can vote in all the matters. And like in most organizations, these ones have the discussions. At the end of the day, they simply vote, they agree on what the standard should entail, and then the standard becomes adopted. Now, those members who are interested, they are allowed to come in for the discussion. And again, this committee is normally prepared if a member has got an issue that they want it to get a standards body, they refer it to ISO, and then a committee is formed to look into that matter. And then all these other guys, they come in, the ones who are interested, and they discuss. And then, of course, after standards come out, then the subscriber correspondent bodies, they will be formed, and then they can participate. Also, these ones, governments, other organizations, governmental and non-governmental can participate. Now, these other organizations like which ones? Well, we do have things like the Red Cross, which cuts across the world. They don't belong to any country, but they can be allowed to participate. Government organizations, well, in Kenya, we have got the the Ministry of Natural Environment. Maybe they want to start to come up with a standard on national environment. Then apart from KEBS being represented, fellows from the ministry can also participate in that one to discuss about it. So it's not the members, other organizations worldwide usually, which have got an interest, can also participate. And then once the standard comes out, it is applicable to the countries who are members. Now, when these standards are formed, like everything, they have got advantages and disadvantages. So let's look at, well, before I look at that one there, how do we identify the standards? So let's talk about standards. Identification. Now first, we need information about the body making the standard. Well, in Kenya, I think we use KS. So KS is a standard by KEBS. BS is a standard by BSI, and ISO is a standard by ISO. Now these are followed by a number . KS, for example, KS 1515. This means is standard number 1515 made by Kenya Bureau of Standards. The number 1515 is the number of the standard. Maybe you can have BS 5750, again the number 5750 is the standard number. And then we have got ISO 9000. This one is the number 9000 standard made by ISO. Now these numbers, I've not chosen them at random. I think one way they are related one to the other. Find out what they are and how they are related to each other. Now those two numbers are followed by another one. The two sets of data are followed by another number, which gives the year that it was established, i.e. came into operation. Okay. If you've got ISO, number is 9001 2008. So this one here is the body making the standard. This one here is the standard number. This one here is the year it came into operation. Now we can see ISO, if it's a standard which has been adopted, it means any country using that standard, whatever it is they are doing, it means worldwide the standards are the same. And these standards, once they are in place, they have got their own advantages and disadvantages. And usually they are adopted if the advantages outweigh the disadvantages. Now, let's talk about the advantages of standards. Now, since there is a standard making the body, there is a standard for the component being manufactured, it means the designs will be safe. Is it safer or safer? I think they will be safer compared to those without the standards. Then, what we notice since there is a standard is mass production is encouraged. Mass production is encouraged. Number 3, the buyer, which is the user, the buyer is safeguarded from unsatisfactory goods and services. The 4th one, now price comparisons can be made easier. Price comparisons. And then, since there is a standard, find that specialization is increased. And then number 6, which is the need for the standards, is that interchangeability of goods and services is increased. Now, this last one is actually the major issue why the ISO came into being. That means the diplomats we have in Kenya here, once they come up with the imported cars, instead of ordering maybe spare parts from wherever they came from, all they need to do is just get a local manufactured product if it conforms to the same ISO. Now, for this to be fulfilled, it means the ISO themselves, they have to be continually checking the bodies which are saying that they conform to their standards. And normally what they do is they use the members. For example, in Kenya, they use KEBS, who are members, to go through the companies which are registered in Kenya to check whether they are conforming to the standards which they say they are adopting for their work. Now, those are the advantages with which I could come across. I think there should be also others. Now, let's briefly talk about the disadvantages. Now, since we have standards, there is a standard of making something in this way. Now, the freewheeling mind we talked about, the design process, can tend to be kind of diminished, which is to say they may cause design incentiveness, that creativeness, to be reduced. But of course, we said if you're a good designer, you should not follow any set pattern when you are doing your own design. That means the standard, there is a standard there. When you are coming with your own design, you don't follow what they say, you follow up your own. And of course, the key thing we know is that these standards can also be revised. Sometimes the freewheeling guy can come up with another idea of how the standard could be improved, and then it starts this process all again. From the body member or that guy sends this to ISO, it follows a discussion, and maybe the standard can be revised. Now, since you are making the same thing the same way, you find that the fellow doing the work may become boring. And of course, this has led to robots replacing humankind. Somebody doing the same thing repetitively can tend to be bored. And the largest disadvantage, which to me I think is a big disadvantage, as we have seen, these standards, they are made by the members. The third one is that the larger organizations may force to adopt the tech expensive innovations to suit new or revised standards set by the large organizations. Now you've got the members, the correspondent, and the subscriber. Those countries with those kind of subscriptions, when the members meet together, they come up with a standard. Then the subscriber members and the correspondent members, if they want to do trade, then they have to adopt the new standard or undertake expensive renovations if they had continue doing business with the other countries. Now that one I think is a bigger disadvantage, especially to the upcoming economies. It's more or less like first world, the third world competition. The bigger boys dictating to the smaller boys. And with that, I think we have set the background of what in the engineering design, drawing, and how we do it. The standards is the mode of communication. So from these ones here, we can briefly talk about the symbols. In much of our drawings, we shall be using symbols to do the communications. We find that there are many ways of communicating information or instructions. That can be either through signs, gestures, word of mouth, writing, or graphics. This is with respect to communication. Can use signs, gestures, word of mouth, writing, or graphics. Now, in the industrial context, we use graphics. The communication being achieved by engineering drawing. And we know the drawings, the conventionally prepared drawings this one's form the main means of communication. Now, for the communications to be effective, everyone concerned must be able to interpret the drawings in the same way. That means if a drawing is made here in Kenya, if we send it to South Africa, the guy reading and interpreting the drawing should arrive at the same conclusion that if the drawing was sent to Brazil and the fellow there reads the drawing, should interpret in the same way. So to ensure uniformity, this is where the standards come in. To ensure uniformity, standards are necessary. Now for this, when it comes to the symbols, we have the BS 3939, and this one, it gives the conventions and symbols to be used in electrical and electronic drawings or circuits. And we have also ISO. As we said, ISO is the global kind of standard. We have ISO 128, which deals with technical drawing, general principles. So much of our drawings will be derived from those two. But you know, much of the world is geared to the ISO standards. Much of the world is geared towards ISO standards. Now come your NEC examinations. Normally, what I find them doing, they rarely quote the ISO. The only time they really quote ISO, BS, or KEBS, they talk about you drawing the internationally recognized symbols of various electronics and electrical or telecom components. And I'm sure KEBS is kind of local, but the BS has got a wider area and ISO has got also a wider area. So drawing either of these figures here, I think it should be okay in your examinations. Now, these symbols, well, what can be taught about symbols? I think it's more or less a case of copy and paste. You simply peruse through books, you see the symbol, you copy it in your notes. So the teaching of it, I'll simply refer you to the books or the internet. What I'll try to do is give the various components which you are bound to be asked to reproduce the symbols. Now, the symbols you'll be asked to reproduce mainly should be the latest. Now, we say the standards can be formed and they can also be revised. So we might find that a symbol was in a standard maybe some 10 years ago. Now the standard has been amended or modified and the symbol has changed. So come examination time, you should quote or draw symbols which are of the latest edition of your standard. Now, the most asked components are, for example, are transistors. Now, with transistors, we know we have got a family of transistors. We have got the BJTs. This is the NPN, PNPs. You should be familiar with those symbols. We have also got the field effect transistors. We have also got the IGFETs, etc. The FETs, of course, we know there is the N channel, P channel, MOSFETs, enhanced depletion modes. All those, either of them you can be asked to reproduce the schematic symbols. And then we have got the semiconductor diodes. Now this one, there's a series of families. We have got LEDs, various types. You have got photo diodes, Zener, rectifier, Tadel, and the list is endless. Then another component which of late I've not seen it featuring anywhere, but you need to be aware of, is thermionic valves. In these valves, they are vacuum valves. The electrons move in vacuums, so the noise generated is usually a minimum, unlike when they are moving in the semiconductor materials. So these ones are usually, the last bit I read, they are normally used in communications whereby you want to eliminate noise. For these ones, we have got thermionic diodes. We have got triodes, tetrodes, pentodes, and modifications thereof. Then we have got resistors. I think the standard for the resistance has been changing for a while. Now these ones we have got the fixed type, variable, and you have got those ones which are sensors. In our diagrams, a fixed resistor, you need to know the type. Is it a wire wound? Is it carbon? And the various types again. Now sometimes you might find the symbol is kind of standard. It cannot tell you which particular component it is. So sometimes you need an index to say the resistor there is blah, 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 so that you know the ones in case the components has to be manufactured. And then capacitors. Again, here of course you have got various types, air capacitors, electrolytics, and the like. And then you have also got fixed, variable, and then we have transducers, converting energy from one form to another. These ones you have got microphones, you have speakers, sirens, buzzers. Again, the list is endless. You have got inductors, coils. Again, these ones come with types. You have got inductors for low frequency, others for high frequencies. Again, they can also be fixed or variable. All these symbols you are supposed to be familiar with to use them in your drawing so that there is no ambiguity. You've also got transformers. We've got voltage transformers, RF transformers, current transformers, and the like. Then we have got rotating machines. Now in the rotating machines, one of the rotating machines we'll be using is motors. Remember, we'll be doing motor connection circuits, and then various types of motors, AC, DC, synchronous motors, single phase, three phase, and the like. And then here we've also got generators, which are also maybe AC or DC, generators, etc. And then with the motors, we have got the starters, which you use to control the motors. The starters, there are various types. For example, DOL, we have got star delta, which we shall be looking at later on, and also many others. And then we have got fuses. In fuses, we have got rewirable fuses, cartridge fuses, high rupture, cartridge fuses, and the like. All those, their symbols, you need to be able to recognize them, reproduce them, and use them in your drawing. Then you have got switches when it comes to the electrical installation. Various types, single pole, one-way, intermediates, and the like. Then we have got socket outlets. Then we have got lighting fixtures. Wall-mounted, ceiling mounting, and the like. And then we have got lamps. Lamps we have got in condensate. We have got discharge lamps, maybe floodlights, etc. Then we have got measuring instruments. the ones we know, the voltmeters, the ammeters, the ohmmeters, you've got the oscilloscope, and others. Now, the list is endless. Now, these ones, as I say, it's a question of just looking at the sample, you know it, and then you ask to reproduce. I think in one of the examinations, there was 10 marks to be got for 10 symbols. Now, teaching this one, I think I'll leave it to you. Maybe give it as an exercise. Now, the components I've listed here, there are also others you have come across in your first year or the places where you went for your attachment. So as an exercise, what I would like you to do is come up with a table. And in the table, have a column for the name of component. For example, here, say for example, PNP transistor. Then you give the schematic symbol. Now PNP transistor, you know, it has got 3 pins, P and P. I think the arrowhead is pointing on the inside, P and P. And then maybe have a column for remarks. But the first column, the first one and the second one are more keen. So I'd like you to list all the various components you know, both electrical, electronic, those ones used in telecoms. List them here, the name of the component, go all the way down, and then the schematic symbols. Now, some of the components, especially when it comes to the electricals, they may be having a wiring symbol. For example, maybe you have a single pole, one-way switch. This one, you know, the schematic symbol is something like that, and the wiring symbol is something like that. And then you have a remarks column. In a remarks column, maybe indicates, if you can recall, maybe the standard or where used. Now this one is more or less for your own information, but these 3, they are very important when you are doing your drawings. So I'll leave you with that one here and see whether you can break a record of, now the last group of learners I had, they had a record of 175 components. Remember, it's both electrical, electronics, and telecoms. Those components, draw their schematic symbols, so that you can come up somewhere approaching that figure. That finishes, is all I want to say about symbols. As I said, it's a question of copy and paste. You just look at the symbol, know it, and reproduce it, maybe use it in your design or something like that. So the teaching you can do here is look at the books, peruse the internet, come up with the symbols. And then when you are doing that, maybe come up with a table like this one here for your future information. Name of the component, schematic symbol, wiring symbol, remarks column may be the standard number, although not very keen, but it helps. In future, you never know. NEC might be specific about the standard. And then just 3 or 4 words, where is it used? Of course, where used might come in with the question of maybe the transistors. Some of these fellows, they're used for low frequencies, others for high frequencies, others for other things. Just make a note of it. Of course, this information, you not find it in one book combined like that. Get it from different books. And that finishes this topic on engineering drawing, the design bit, the standards, and the symbols, which is what we use to do the drawing to communicate our ideas. So after this, I think we can start off with the actual circuits.